Hello, everyone, and welcome to today's webcast. My name is Jake Freevold, and I'm Vice President of Product Marketing at Information Builders. I'm here with Neil Radin, a friend and colleague for quite a long time. He's the principal behind Hired Brains. And today we're going to be talking about accelerating speed to insights with trusted data. One of the things that we focus on at Information Builders is trusted data for better analytics, and that's what we're going to drive toward today. It's going to be a little bit more of a freewheeling approach than you may be used to, though. Instead of your typical 30 minutes with the analyst and 20 minutes with the host and another 10 minutes for Q&A, we're going to spend about 10 minutes with Neil presenting some slides and discussing some of what he wants to talk about, a little bit of my perspective for about 10 minutes with slides, and then the rest of the time, about another 25 minutes or so, is going to be a discussion between me and Neil with only light editing. So what you hear is what you get. It's also worth noting that while I'm sitting here in Manhattan, where bandwidth is abundant and plenty, Neil is in Santa Fe, New Mexico, which means his bandwidth is a little bit more constrained where he is, and you might hear a little bit of glitching. But again, we thought it was a good thing to get as raw footage as possible so you could hear what's really going on and get a feel for what we're talking about as we say it, the way we say it. So with that, I'd like to introduce Neil Radin. Thanks for being with us.
Thank you, Jake. It's a pleasure to be with you and a pleasure to be working here with Information Builders on this presentation today. Yeah, I'm a technical math kind of guy from way back. I was an actuary. I started a consulting company many years ago. I've been involved in analytics pretty much from start to finish. And I wasn't an IT guy. I wasn't a data guy. But it occurred to me about 10 years ago that I needed to get serious about data. It wasn't all about models and presentation. We had to really get our arms around data. So I've been very serious about this lately, and I've looked very carefully into what technology providers like Information Builders are doing. I should add that I actually worked with Information Builders something like 25 years ago, developing applications in Focus, but that's ancient history. And Edda-SQL, which became iWay, and so forth. So I've always had some affection for this company for their approach to data. And that's what I'd really like to talk about today. Well, we've all heard about this 80-20 data prep problem that analysts and data scientists are spending 80% of their time just trying to manage data and only 20% of the time on useful applications. Honestly, I don't know if that number is true, and it's certainly not true universally. But the fact that that number or that ratio has endured for 5 or 7 or 8 years now means there is definitely a problem. And the point of the graph is that we want to move from 20% of the time wrangling around with data and 80% of the time with doing things that are useful. So our research into this topic shows a couple of things. That coherent connected processes for data management are really key. And Jake and I are going to talk about that in some detail in a minute. And not manual wrangling, which is what we've done in the past. However, I do want to make a point. And that is that not all data science or advanced analytics or predictive analytics does necessarily require the galactic analytical approach. I've been working with a couple of groups of actuaries in health insurance companies. And here you have a group of 3 or 4 actuaries working on, say, pricing analysis. Their requirements are very different. Their semantics are very different. And they kind of manage their own data themselves, and it doesn't really apply very much to the rest of the organization. So I want to make the point that there are cases where people will be doing their own data management absent of a galactic kind of data management tool. But there's no question in my mind that every company really needs to be looking into a way to really get their arms around data. And that involves not just where the data is in a technical way, but understanding relationships and embedded connectors and that sort of thing. Because data discovery is dynamic. It's not a one-time mapping. You can go out to a bunch of data sources and figure out their semantics and map them into something. And by the time you're finished, things have changed. So you need support from technology to keep going on a regular basis. Another big problem, of course, is AI-driven discovery. And it's becoming sort of a must-have. I think there are a lot of organizations that are away from that. But you can't do machine learning or AI without gobs of data. And unless you want an army of programmers and data engineers trying to support the efforts of the people who are coming up with these kinds of solutions, you're really not going to get anywhere. Rules really aren't sufficient. We used to do it that way. You know, if this name is like that, and if that name is like this, then we're going to put them together. They're still useful, but they're not the whole picture anymore. And no algorithm for figuring those things is really sufficient out of the box. When a machine learning algorithm looks at data and tells you that this data is related to that data, you really need human experts to look at those results and edit them. And you especially would like your software to be able to make corrections back to the source systems if possible, and also to take the edits, the changes that your data engineers or your data stewards have made and feed that back into the data pool to improve machine learning algorithms. Now, I use this term deus ex machina, and what I mean by that is beware of companies that tell you, don't worry, we have machine learning, it will take care of everything. And it just reminded me of Greek tragedy, where at the end of a Greek tragedy, the plot had gotten so convoluted that the only way they could figure it out at the end was to have a god come down and fix it all. And that's what I mean by the ghost in the machine. And you need to be careful with that, because if they tell you they have machine learning, they're certainly not going to tell you what their algorithms are, but you'd at least like to understand how it operates. So the components of this intelligent data discovery have to be relationship discovery. You can't just map one data source at a time. You have to be able to figure out how they relate together, because that's the real holy grail. And in addition to that, you really want to understand data flow in the organization, how often things change, and if you can capture that and match that into this constant cycle. And we all know that sensitive data discovery is a really, really big deal right now. And it's a big deal for a couple of reasons. Obviously, you don't want to divulge people's social security numbers and a lot of sensitive information. But there's an even more insidious problem with sensitive data discovery, and that is that this personally identifiable information, they call it. So it's easy to mask a social security number or a name or an address or whatever you want to do. But the problem is any evil hacker can look at a bunch of data sources and work backwards and figure out who those people are, even with those masked identities. And this is a problem that's way too complicated for you to do manually. It has to be done with good software. And the third thing, of course, is mastering. Every organization needs to be looking at a way to create master data management for, God, at the least, customer and product. And that's a big chore, just as it is. But it has to be done on an enterprise basis. And I know that's hard to do, because sometimes it's hard to define just what the enterprise is. But the alternative of that is a lot of MDM initiatives that happen on departmental or group bases, and that wastes a lot of time and creates a lot of confusion. Now, let me talk about relationship discovery for a minute. The really important part of managing unalike data, and I mean, what is unalike data? We used to have ERP, we used to have our own internal legacy systems and CRM and that sort of thing. Unalike data is everything else. It's data that you don't own, that you don't control, that's still critically important to you. And manual methods for finding the relationships in unalike data, you're never going to be able to do it except for the most simple applications. The other problem is a lot of metadata that's created by tools today is strictly technical metadata, like where it is, when it was updated, what the column names are, and so forth. But the real magic happens when you actually look at the data in the columns themselves, and that's where you can find out what's going on, what's related to what. If we have time, actually, I'm going to tell you this story anyway. I was talking to somebody who works at one of the big auction houses. And apparently, this young intern was given the job of writing the catalog for the upcoming auction, which was about first editions and autographs and signed letters of famous people and so forth. And basically, he didn't know nothing from nothing. And what he had to do was photograph each piece, write a description of it, and create a range, a bidding range that the auction house expected. So he got a copy of a book called A Connecticut Yankee in King Arthur's Court, not one of Mark Twain's most famous books. And it had an inscription in it. It was signed by Mark Twain. Actually, I think it was signed by Samuel Clemens. I can't remember. But it said, "To my friend Nicola." And he looked at it and said, "Well, you know, it's a little frayed and, you know, blah, blah, blah. I'm going to put a range of $500 to $750." Well, it turns out that this auction house has a very extensive database, in fact, a graph database of every important person and their relationships. And when he punched in this name, Nikola, with Mark Twain, it turned out that Nikola was Nikola Tesla, one of Mark Twain's best friends. And the price of the book skyrocketed, but he almost missed it. So the value of relationship mapping in data is that it can actually tell you more than you've asked for. And that's really important today. The other thing is the process that flows through data collections really should build some sort of a relationship. Now, I don't know if it should be in a graph database or it should be a graph view on top of some other data store. That's a technical argument. The point is that graph relates things, and a relational database pretty much doesn't. So to get that relation map, you're going to need some technology to do that. Now, data flow is really important too. Now, I don't know anything about tRNA transcription. My wife tries to explain it to me, and it's just way over my head. But the point I'm trying to make is data flows through an organization, sometimes in a very complex way. And when you look at this genomic process, you can see how many different domains communicate with each other. You couldn't really understand anything about tRNA, like I don't, if you only map each of those squares. So you have to have something to do with it. And as far as I'm concerned, it's a good example of data flow and how these various schema can interact. Sensitive data discovery. And I've already talked about that for a second. But looking at the data itself, an algorithm can actually decide the data is within the realm of sensitive. Now, I know that we talk about GDPR and HIPAA, but there's more of these coming on the way. UK has DPA, California has CPA. I forgot who, EPR is the European Union, another version of this. So if you're managing data that has that kind of sensitive information, you really need to have a tool that's going to help you figure that out. You cannot possibly do this on your own. The same thing happens with redundant data. If you've worked with data at all, you know that you get the same information in lots of different sources. And the analyst always chooses which to use. Generally, we don't have redundant data in enterprise data, though it happens. But other types of data sets creep into your universe of sources, including not just source data, but data that you create yourself, such as outputs of analysis and training data sets and versions and even spreadsheets. So you need to understand that, and this is another thing that your tool has absolutely got to help you with. What do you have to provide? I call this the big fish. You have to have a means to find the data that you need, and you have to understand it. Now, you know, what does it mean to say understand it? That's a tough question, but for an analyst, they have to have a way of looking at available data and having a pretty good idea. Let me digress for a second, talking about those actuaries. There were two groups of actuaries in the company. There were the pricing actuaries, and there are the valuation, reporting, loss reserving actuaries. Now, the latter group, they deal with statutory requirements. What they do has to be right. The pricing actuaries are a little loosey-goosey because they just want information fast. They want to see changes and trends as they happen. So understanding what the data means may be a little bit loose for some groups, and that's acceptable. So the notion that everything has to be perfect and nailed down is probably not productive. And the other thing is, if your process can't support collaboration and useful data governance, well, you know what, then you have a problem. Now, data governance is an interesting topic. Before, at least in my mind, data governance really meant what you wouldn't let people do. Today, data governance means how you help them do what they need to do. And it's a different world, right? And I think that governance is something that can happen organically from both bottom up and top down. In other words, I like to use the assumption that people who work in this field are well-intentioned. And if they're well-intentioned, then they're adding to the process of governance. So your governance tools have got to be something that's not just a blueprint that's passed, on high. It has to be collaborative. And it's really amazing to me to see the technology evolving to do that. So, my point here is I like to use the term the culture of possibility. In other words, I'm going to solve this problem versus, this problem's too hard, or it's 80-20. Now, machine learning is rapidly helping, but I don't know how to gauge how rapidly it's helping. Obviously, lately we found that machine learning has a lot of serious problems in terms of bias, for example, in terms of explainability. If you're using things like, neural nets well, Bayes are better, but if you're using things like neural nets, it's devilishly hard to explain how you got to a conclusion. And management, who doesn't really understand the technology, is going to have a very hard time, pushing the go button if they don't understand it. But data discovery really reduces the time to digital transformation. And I keep coming back to the same point that you really need good tools. And the important, I shouldn't even say good tools, because it's really, really important that people who work with this don't have to jump from one tool to another to get the job done. Because each one of those hops adds latency, adds error, adds lack of attention. And to the extent that you can find software tools that take you from one end to the other, you're going to be better off. And that's where I think we're going to kill this 80-20 problem. Well, Jake, I'm going to turn it over to you. Okay.
Thanks very much, Neil. For those of you who are listening, we're going to have a bit more conversation with Neil in just a few minutes. What I'd like to do is take a couple of seconds to talk through what Information Builders thinks with regards to some of these topics and how our technology plays a part in data management that makes business analytics more effective. Okay, so I'd just like to think a little bit more about data discovery, AI, and machine learning. And as I do so, I want to think about data scientists and other so-called self-service users. Now, it seems to me that analytics is one of the very few industries where self-service means I can do anything that I want to do. If you go to an airport kiosk, for example, self-service means you've got a very focused business problem, and they're going to help you check in and do things of that sort, see whether or not you can get a better seat, et cetera, and they provide all that context for you. But in the world of BI and analytics, where self-service really means that we are providing an ability to access any data and do any kind of manipulation of that data to get an answer that we want. So in a typical self-service kind of environment, what we'll very often see is a kind of one and done process where data scientists take information from a data lake or from some other data sources. They'll source that relevant data, and they will pass that information on to the CMO, the customer service manager, the CFO, and other people who are responsible for some part of the business who need some kind of an answer to a question. And their job is really to generate some kind of insights. And very often this one and done process goes on forever, basically, until someone figures out that they can gain more information or gain more benefit from the insights that are generated. So let's say a customer service manager sees that one particular insight is really relevant to something they're trying to accomplish, and they want to provide that information to more and more people. One of the benefits that I think we're still learning how to access within our modern environments is how to make the business and the data scientists collaborate to create repeatable insights. Taking the information from the data lake and hardening, if you will, the process, making permanent or industrializing the process of getting that information to a standard form, and then providing those insights to larger numbers of people. Now, obviously, if you're providing to larger numbers of people, they'll have different questions that they need to answer. and therefore you probably want to parameterize that information and be able to provide insights in different ways, even though it's related to the same, in this case, perhaps customer service problem. So by being able to identify the appropriate users of the information, defining the parameters associated with the information, and then deploying those insights out to dashboards or mobile devices or embedding them in Salesforce.com or whatever it might be, you're able to take some of those really strong benefits and insights that our data scientists are generating, and make sure that they survive in order to help the business do more good in order by using that data and information in a much more appropriate way across more and more people. So this kind of collaboration aspect of things is something that's important. Everything that Neil talked about before really does involve gaining some kinds of insights and discovering information that's in the data sources that you have. But you also need to harden that off and make it so it's not a one-off process, but something where the data is made available to lots more people over the course of a longer period of time. And when we talk about providing information for AI and machine learning and other forms of analytics, one of the major issues that we see as a vendor is trying to provide the data in a time frame that makes a difference to those people. Very often we find that data scientists and analysts use tools that they want to use, they get the data that they want to get, and they really don't want to be told one way or the other that they are not going to be able to do those things. So by providing some curated data that's useful to them out of the box and being able to allow them to integrate other data into it, but reducing the amount of work that they have to do to make that happen, I think becomes very important. And let's talk through some of the issues we've seen in getting to that point. One of them is data modeling. We spend a lot of time coping with very small changes in our business data. It's really easy to take a first, a middle, and a last name and create a name out of that. But if your applications have to deal with people from other countries, people with different kinds of names, order to their names, whether like Asian names or things like patronymics in Russian names, when people start to make changes in their applications to handle those names, they start to make significant changes that then have to get passed on to the data sources that would be curated. That would be a data warehouse, let's say. And that frequently takes place in a longer sequence of time that makes it very difficult for data analysts to take advantage of it. So how do we handle the fact that there are repeated changes in our operational systems, row and column structures? The traditional ways of doing that have been very difficult. We've created the operational data sources that are designed for transactions. We've moved them into data warehouses, which are designed for abstractions. And then we've moved it from there into data marts or certain kinds of extractions designed for analysis. How do we shortcut that process to the greatest extent possible so that a data scientist or an analyst can simply go to a data source and say, give me the information I need, and I'm not really worried about details that are extraneous. Don't hem me in by making me deal with things that I never had to deal with in the past. That's one of the things that we have to overcome if we're going to make the data that we have accessible to data scientists and analysts in a way that's going to be fast enough and accelerated in a way that's going to allow those insights to propagate throughout our organizations. Another problem has to do with that industrialization process. I said before that if a data scientist can create insights and then an executive or a leader, business leader can take the information that they've presented and provide that to people in a significant way that helps them use those insights, then they can gain a lot more benefit by having 6,000 people using it instead of 3 smart people in a back room somewhere. One of the things that's become very hard to do as we industrialize those processes is create an environment in which everything that we've done to the data is understandable, and this is really especially important in some of those environments that, in some of those requirements that Neil talked about before, like GDPR. So, for example, right now, if we have stuff coming from an operational application that has to do with a person, and from another different cloud application that pertains to the same person, as we bring it into the data warehouse, a lot of the transformation and cleansing and standardization happens in different processes. Even if we're trying to fire the same rules, if you will, the same kind of cleansing rules, they get fired in different places. And that means there's a serious problem with synchronizing and making sure that the information is correct and consistent across all of those transformations. Because cleansing occurs in the transformation step, we see different rules getting fired, things get out of sync. We have different tools and different metadata being used depending on the platform. That causes inconsistencies and problems in understanding the provenance of the data. We lose context. We can't audit across the different platforms, which means that we have a really hard time saying what the real impact of our insights are, or even whether those insights are valid, because sometimes those insights are not going to be able to be audited appropriately. And we have no comprehensive rollback. We have no alternative history. True story, my mother's name is Sue Freevold. My wife's name is Susan Freevold. And if you don't think I have to be very careful about whom I text what to, you got another thing coming. Well, it turns out that they both have a Discover card. And one day my wife started getting updates about my mother's Discover card transaction activity. That's a major issue. And clearly it's a result of some kind of a bad merge somewhere, and it's something that should be fixable. But we've tried 3 times, and every time that we go back and we say, here's the problem, please fix it, and they end up having the same kind of bad merge happening. If we do this right, if we did not have processes that integrated data across different platforms in different ways, it would be easier to say, let's back up to the point in time where the bad merge was and rerun history after putting in place a rule that says never do that bad merge again. So instead of trying to disentangle all of the different interconnections that happen after the bad merge, we're able to simply say, let's rerun history as if Sue Freevold and Susan Freevold were identified as 2 different people all along. That kind of thing typically isn't possible with the kind of cross-platform processes that we have. So if we think about how we want to do integration from a modern perspective and avoid those problems, one of the things we can think about is how do we stop spending so much time mapping one set of rows and columns to another. And a modern solution might include post-relational subject-oriented documents like we use in typical new applications for data capture transformation, maybe for storage and exchange, instead of using relational models. You can import these kinds of things into graph databases, you can import them into applications, you can import them into lots of different places because they are not based on the row and column models that we've dealt with before. So in other words, as operational applications go to the warehouse, and as the warehouse extracts information for analytics, I'm asking for the subject, and the subject comes along as a whole, and that can streamline the process of getting information from one place to the next. And if it's stored in that way, then you don't have to worry about transforming it into some underlying model as part of the store. How much information are we losing by distributing our ETL processes and having these distinct business processes in place? One of them is to use ELT to capture and integrate. This is something we learned from doing data lakes, that it was better in many cases to bring all of the data into the data lake and then do our transformation in one place so we can track everything that's going on as it happens. If we can do that and timestamp everything and do it in a subject-oriented way, then we can capture the data as it exists in those operational systems, apply trustworthy processes to it across the board so that the same processes are being repeated, the same rules are being fired, the same information is being captured and tracked, and then we can share it in trusted ways. That makes a huge difference to our ability to manage the information that people are asking for. So I call that a data capture and transformation hub, where all the transformation, cleansing, and standardization happens in one place, and then in a subject-oriented way, we ask for the data necessary to apply to those business cases. One of the places where we've actually done that in a data-first kind of a way was with our Omni Health data application. We look at the data use cases that people wanted to apply data to, whether it was applications that were downstream, whether it was pre-built info apps that would enable people to run their healthcare organizations, or whether it was ad hoc kind of BI, AI, and ML kind of requirements. And then also external requirements. How do I benchmark things? How do I share things in a health information exchange and so on? In order to do that, we work from those data use cases backwards. We say, okay, how are you going to connect and consume the information, connect to and consume the information that you need? How do I build a model that gives you 360-degree views of these things so that I can provide the consumption and metric views necessary to connect and consume for those applications? And then where do I find the information necessary to be able to map into those and apply to those the quality standards, the reference data, the attribution and mastering, and so on that are necessary to provide that data, and then go out to the data silos and say, okay, well, here's the system of record for these bits of data, go and map those bits of data in. interestingly enough, taking that information from the working backwards, taking that information from the use cases all the way back to the sources of record, enables us to create views of the data in much faster timeframes than you would do in a traditional data warehousing environment. Partly because we are building in best practices in ways that normally don't get done. We automatically generate the data hub. Those data hubs are normally, if you're trying to timestamp everything and provide every single before and after, those are incredibly complex and really difficult to do analytics from. But because we can automatically generate the data hub and automatically provide the views into that data, that provides a tremendous amount of value in a much shorter period of time. By mastering the data in a business user-oriented and subject-oriented way, we're making sure that we can enable you to get the data that you need based on your use cases and not simply try to wire together a bunch of data, which is getting the cart before the horse. There's more that we could talk about here. The key ones for me are really about the rapid cycle times that we need to keep the business engaged. Very often these processes take 6 months, 12 months, 18 months, and by the time you go back to the business with something, the business has changed. And because the business has changed, what you've built isn't appropriate for what they want to do. The way this fits into the data quality for better analytics, like we were just discussing, is that you have to be able to make changes rapidly, even when things like the names were changing that I talked about before, in a way that's fast enough for the data scientists to not just go out and build it all themselves. It has to be data that they say, okay, well, I need the following information in it. We incorporate that information into it, and they can get results back extremely quickly without having to go through their own custom processes to get it done. Finally, just to note that we have persona models for customer and suppliers. So for those particular models, if you want something pre-built where the match merge rules, the data quality rules, and so on are all built, those are available for customer and supplier out of the box, along with the Omni Health data, which is a complete solution for healthcare. So just to put this in perspective, when you're using typical data management tools, you're talking about building it yourself. A typical environment like that might take 12 to 18 months. With OmniGen, we're talking about something that's more like 4 to 6 months. Pardon me, if you're trying to just do that one persona by itself, then that's something you can do in something more like 1 to 3 months, because a lot of it's built directly into the business process that's built into that OmniGen process. All right, so with that, what I'd like to do is I'd like to go back to discussing with our guest, Neil Raden, a little bit of the conversation that we've had before. This is going to be a little bit more freewheeling. And Neil, thank you very much for being willing to take this little gamble with us. So I had a couple of questions, if you don't mind, regarding some of the things that you said. And one of them is, how do data scientists assess the quality of the data they're getting? It's one thing to bring it together, but it seems like it's another to make sure it's suitable for its purpose. How do they do that?
That's a tough question. When it comes to data scientists, I like to break them down into 2 categories. And like Mark Twain said, there's only 2 kinds of people in the world: the kind who think there are only 2 kinds of people and the ones who know better. But realistically, the data scientist who gets a phone call or an email and says, one of our competitors just got a fast approval from the FDA for this new drug. I need you to get back to us on what our marketing and pricing should be on our existing products and so forth. Okay? So this is an emergency project that he hasn't had to do before, or she hasn't had to do before. And whether or not he has qualified data sets and so forth to solve that problem is not given. Now this is a problem that doesn't occur every week, right? So this wouldn't have been set up as an application. I know that the late great Thomas Hobbes said that it takes great energy of mind to create a system. It requires even greater not to become a slave to the creation, right? So I think that to the extent that data scientists or analysts, or whatever you want to call them, they're doing work on a constant basis, they're looking at similar problems and so forth, data quality is extremely important to them. When I mentioned the actuaries, the pricing actuaries, they feel like if they're at 80%, they're okay. The valuation guys have to be at 100% or they're in trouble. So how do they get to data quality? My understanding is, I mean, they use tools, obviously, but they do a lot of comparison. They look at output based on different flows of data and see if they're getting the same results, and then they work backwards and try to figure out what went wrong. that's the 80-20 thing. It's very time consuming.
And it's typically a
Yeah.
manual
Well, you know,
process, even though they're using tools, there's
Yeah.
a lot that they have to do on their own, huh?
But think about it this way. Remember cooking shows? And I don't mean the competitions. I mean like a great chef showing you how to do something like Julia Child or Martha or Emerald. If you looked, they had everything they needed right in front of them. Everything was measured out in different containers. The sink, the stove, the oven, the chopping board, they were all close by. So when they can put this recipe together, they can just really go with it. When I cook something, I'm running around the kitchen and the pantry trying to find things. And I think that's what a lot of data scientists have to do. And the ones that really have their act together are more like those chefs.
One of the interesting aspects of what you talked about had to do with the difference between people shepherding the machine along and the machine shepherding people along, and I'll explain what I mean by that. Obviously, when we're training machines to get better at doing things like identifying PII, we can start with knowing what a social security number looks like, but then people have to guide the system along to understand, oh, that looks like a partial social security number, or that looks like a partial telephone number, or whatever it may be that it looks like. So humans have to guide the machine. And at the same time, like your story with Mark Twain and Nikolai Tesla. I had no idea that they were friends, by the way. That was really interesting. There you had a person who needed to have the machine smart enough to be able to guide him along and shepherd him to making better decisions. So how do those two things interrelate, and what's different about them or better about them, one or the other, or are they just part of the same process?
No, I mean, machine learning is a pretty broad topic, right? I mean, classic machine learning, most of what we know as machine learning, is basically somebody taking a bunch of data, maybe labeling it, creating a test set. They already know what they think the answer should be, and they run it a zillion times until they get something they like. They don't know if the data's been biased. They don't know if they've inserted bias themselves, and they're basically trying to draw some insight out of data. I like to say when you do machine learning, you start with the assumptions that you don't know anything. As opposed to, say, a Bayes network, where you start with the fact that you do know something, and then you work backwards from there. I think the data scientists deal with data quality in a number of different ways. Like the actuaries, the pricing actuaries, they're happy if they're directionally correct because they don't have statutory requirements. They're just trying to make the best estimate how to price these policies, whereas the valuation people have to be dead on. So they're killing themselves trying to get everything exactly right. And the way they do it, that I've observed, is they generate this information from different sources. They bring it into, guess what, Excel spreadsheets, and they start to compare it. And if the numbers have variance, then they go to work trying to figure out why. It's a horrible process, right? So I think that machine learning guides human beings to a certain extent, but I think that the process where human beings look at the output of an algorithm and say, well, no, that's not quite right. Let's put that in there. Let's adjust these weights or whatever, and then run it again. So it goes both ways.
And Neil, do you find that people are able to take the rules that they've generated, the cleansing or whatever they've done, and make those, incorporate those into the enterprise in some significant way? And one of the things that we've spent some time on with OmniGen is trying to make sure that if you do something, that it gets bubbled up to the broader process. We want a business person to be able to say, here's a rule, a remediation rule, here's a cleansing rule I'd like to apply to my data set. Now, I want the opportunity to raise that up. And you can't do it willy-nilly, obviously, but it would be good to get that knowledge and bubble it up. Is that something that people are able to do right now, or is that something that they're still struggling with? Is it a significant problem or no?
I like to use the metaphor of standing on the shoulders of giants. The people who developed business rules over the years were conscientiously trying to encode things that made sense. And if you just want to throw away the baby with the bathwater and say, the hell with that, we just are going to use machine learning, I think that's a mistake.
So Neil, one of the things that you talked about in your presentation is that everybody has some kind of data stores for customer and product, but when they get that properly mastered or whatever it may be, there's still 90% of the data that's necessary for data science and analytics left out. Can you talk a little bit about the kind of data that people do leave out and the kinds of data that they should think about incorporating into, their more governed stores if they're going to be, supporting data scientists and other analysts?
Well, if there's a zottabyte of data out there, there certainly is a zottabyte of customer and product data, right? There's weather data, there's demographic data, there's census data, all kinds of government and NGO data that's published and so forth. And it depends on the application. I mean, if you want to do, BI, OLAP analysis of, a customer profitability, product, movement or that sort of thing, you don't need any of that data. And if you're pulling data from, say, ERP or other mature systems, even though there is redundant data in those systems, the understanding of where the data is and what it means is good enough that you don't have to worry about it. But when you start pulling out this plethora of data from other sources, you're going to have all kinds of redundancy and conflict.
Okay, excellent. Thanks. What I think, those are all the questions that I had. Neil, is there anything that you wanted to talk about and get on the record before we wrap it up?
Well, there are a couple of things I wrote down here. The title was Accelerating Speed to Insights.
Right.
So I kind of wanted to talk about speed for a minute. What does speed really mean? You can have the fastest system in the world and the most optimized queries and everything running perfectly. But speed is, for a person, cycle time, meaning from the time I start something until the time I finish it, how fast can I go? And if you can give time back to a person, that's better than gold. If you can give back somebody 10% of their time to work on, that is a fantastic thing to do. And as far as I'm concerned, the way you do that is you don't give them cobble together a whole bunch of different products to try to do the job.
That's probably true whether you're talking about the data side or the analytics side. It's the entire process from sourcing through final answers.
Yeah. Now, the other thing we talked about for a minute was trust. I don't think any programmer could ever program a computer to understand the concept of trust, or harm for that matter, when we talk about machine learning, right? So how in the world can you get trust into the data? It's not something that can be completely automated. It has to involve the human element and people to look at it and say, yeah, I trust this.
And that's something that's not going to be replaced by machine learning anytime soon. That's going to be something that a person has to say, here's where I get to. How do you relate that to, the kind of black box situations like you were talking before with, a neural network is going to spit out an answer, but good luck trying to figure out why it chose that answer versus others. How do you relate that trust factor to that kind of situation?
And it's even worse with deep learning, right? With layered neural networks.
Yep.
I read an academic paper recently. I wish I could cite it. I don't remember. But apparently some researchers are making some progress on the explainability of deep learning adversarial neural networks. I can relate to a personal experience where we did a dynamic pricing study for a consumer products company a few years ago. And we used machine learning, advanced statistics, the whole thing. And we had to present it to the CMO. And at the end of 3 months, we had whiteboards around the room, and she came in and we presented everything that we've done in our conclusions. Never used words like, like gradient analysis or anything like that. Just things that she could understand. Well, that's not fair. I shouldn't say she could understand. Things that were familiar to her. And after 3 hours, she looked at us and she said, well, nice work, guys. Let's keep talking. And you know what that meant. Wasn't convinced. So that is a big problem.
Yeah, business people typically don't trust black boxes, and we have a lot of black boxes growing up around us right now, but they're also convinced, and this is interesting as a marketing guy, right? They're convinced that these black boxes of AI and ML are going to change the world for them. So it's an interesting split in mentality that we've got right now. All right, well, thank you, everyone. This wraps up our webcast for today. I'd like to thank Neil Raden of Hired Brains. Thank you, Neil. It's always a pleasure to do business with you and to hear what you have to say, listen to your insights. Thank you very much for being here today.
No, thank you, Jake. It's a pleasure working with you, too. Thanks for having me.
Thank you, everyone.